Anthony Raj. He has pursued his bachelor's, master's and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Thiruvalluvar Arts and Science College and Idea Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series B.Arc Mathematics Semester 1 Lecture 14. In this lecture, we are going to see basic statistics. In basic statistics, the arithmetic mean, median and mode. These are all some of the fundamental concepts to be learned to do the statistics effectively. The arithmetic mean. Before going to the arithmetic mean, let us know something about the statistics. Statistics is a subject which deals with the methods for collection of data, classification of data and analysis of numerical data. In statistics, mostly numerical data are considered. First, you need to collect the numerical data and classify the numerical data, then analysis. These steps are followed for drawing a valid conclusion about a particular problem by taking various samples. By analyzing the samples and the number of samples, a valid conclusion can be obtained. Based on that conclusion, some reasonable decision can be taken. This is the use of statistics in various fields of science and technology. In that statistics, some fundamental concepts like mean, median, mode are very important. Let us see what is the meaning of mean. First, to understand the meaning of mean, consider different samples. If x1, x2, x3, etc., xn are a set of n samples or values of a variate. That variate can be anything like marks if you are analyzing the marks of the students, or if you are analyzing the population of a state or a country or a world. These x1, x2, x3, xn can be a set of n values of a variate. Then the arithmetic mean, or simply it can be called as mean, is given by x bar is equal to x1 plus x2 plus x3 plus etc. plus xn over n. That means we have to add all the samples x1, x2, x3 and divide the sum by number of samples. This can be symbolically written as summation of xi, where I can take values between 1 to n, and n is the number, total number of samples. So this is how you can find the mean of a sample. In a frequency distribution, if these x1, x2, x3, etc., xn be the mid values of the class intervals, here you have to take the frequency distribution. Those frequency distributions are about mark distribution or some age distribution, gender distribution, like that. Anything can be considered as a frequency distribution. If these x1, x2, etc., xn be the mid values of the class intervals having frequencies f1, f2, etc., fn respectively, then arithmetic mean, or simply mean in that case, can be computed using this formula. That is, the arithmetic mean is equal to f1 into x1, that is frequency of the first distribution x1 into the distribution. So, f1 into x1 plus f2 x2 plus f3 x3 etc. plus fn xn over sum of all the frequencies f1, f2, f3 etc. fn. This is how the arithmetic mean of a frequency distribution can be computed. In simplified form, this arithmetic mean formula can be written as summation of fi into xi over summation of fi, where I can take values between 1 to infinite. So, this is the definition of mean in two cases. A simple definition about mean, that is a summation of xi over n, and definition of mean in a frequency distribution case. In frequency distribution, mid values of a particular frequency distribution and the frequencies are considered, then sum of product of the mid values and the frequencies are in the numerator and the sum of the frequencies are in the denominator. This gives the arithmetic mean in case of frequency distribution. Now, let us come to the calculation of this arithmetic mean. There are methods to calculate this arithmetic mean. If you apply this arithmetic mean calculation directly to a grouped data, then it will be very complex, very difficult. So that some technical short methods are there to calculate the arithmetic mean. Those short methods are two types. The first one is shortcut method and the second one is step deviation method. In shortcut method, the arithmetic mean is calculated by considering this formula, that is arithmetic mean x is equal to a plus sum of fi di over sum of fi, where here this d is equal to x minus a, where x is the normal mean and a is an arbitrary origin. That means first you need to fix an arbitrary origin in the group of data, then from that arbitrary origin the arbitrary origin should be subtracted from the x data, then you will get that d, then summation of that frequency. So, this is the formula to calculate arithmetic mean in shortcut method. The next method is step deviation method. In step deviation method, arithmetic mean x is equal to a plus h into summation of fi into ui over summation of fi, where this h is the class interval in this case. In the shortcut method, that class interval does not appear, but here in step deviation method class interval appears. Then other than that class interval, one more term appears here in the step deviation. That term is u, where u is equal to x minus a over h. You know, x is the particular variable and a is an arbitrary origin, then h is the equal class interval. By doing this manipulation, we will get the u value, then that u value can be multiplied with the frequency, then sum of that u frequency multiplication is obtained, that will be the numerator in this case, then sum of the frequency alone will be the denominator in this case, then that is multiplied with h. That means this component is h equal class interval times the component plus the arbitrary origin will give the arithmetic mean in step deviation method. From this arithmetic mean explanation, following observation is obtained. The algebraic sum of the deviations of all the variable from their mean is 0. We have calculated the arithmetic mean. The calculation of arithmetic mean involves sum of all the variable over number of variables exist. This is arithmetic mean. The algebraic sum of the deviation of all variable from their mean is 0. That is explained equationally in this case. That is, for summation of fi into xi minus the arithmetic mean is equal to sum of fi xi minus x arithmetic mean into sum of fi, which is equal to sum of fi xi minus sum of fi xi over summation of fi into summation of fi is equal to 0. Here in this equation, this summation of fi will get cancelled with this summation of fi. So, remaining thing is summation of fi xi. So, this is subtracted from summation of fi xi, which is equal to 0. This is how equationally the algebraic sum of the deviation of all variable from their mean is 0 is proved. This is the observation from the arithmetic mean. Then a corollary about that arithmetic mean. If x1, x2 be the means of two samples, for example, x1 can be a mean of marks of 10 students in mathematics, and x2 can be a mean of marks of 10 students in science. Then size of sample is n1. I told marks of 10 students, so n1 can be 10 and n2 can be again 10. If you can vary that n2 as 20 also, then the mean x is given by x is equal to n1 x1 plus n2 x2 over n1 plus n2. That is, n1 is the number of students in the first case, x1 is the mean in the first case, then n2 is the number of samples. In general, we can call this as number of samples. X2 is the mean for this number of samples, then sum of the number of samples will be the denominator. So, here two samples are considered, and how to calculate the arithmetic mean for that two samples can be solved using this arithmetic mean formula. This is the corollary of arithmetic mean. There n1 x1 is equal to sum of all observations of the first sample. In this, n1 x1 is the sum of all observations of the first sample. Then n2 x2 is the sum of all observations of the second sample. Then this sum of the observations of the combined sample is equal to n1 x1 plus n2 x2. Then this n1 plus n2 is the number of observations in the combined sample. So, mean of the combined sample can be obtained like this. Here two set of samples are considered. Instead of this two set of samples, you can go for n set of samples. So, this arithmetic mean formula will change as n1 x1 plus n2 x2 plus n3 x3 etc. nn xn over n1 plus n2. This is what we said in this case. This is this case, frequency case. This frequency case is similar to this corollary. Next, median. So far we learnt about mean, which is a fundamental concept in statistics. The next important and fundamental concept in statistics is median. Median means middle. Very simple way you can call that median as middle. If the values of a variable are arranged in the ascending order of magnitude, then the median is nothing but the middle item of the sample if the number of samples is odd, if the number is odd. Suppose the number is even, we need to take the mean of the two middle items. If the number is even, then that will give the median. This is the basic understanding about median. So, if the values of a variable are arranged in the ascending order of magnitude, the median is the middle item if the number is odd and is the mean of the two middle items if the number is mean. Thus, the median is equal to the mid value, that is the value which divides the total frequency into two equal parts. So, if you are given a sample 10 number of students, if you are asked to find the median of that 10 number of students, you need to consider the fifth one and sixth one, take average of that fifth one and sixth one, that will be the median of that sample. Suppose 9 number of students are given, then just go for the fifth one. In the starting 1, 2, 3, 4 and in the bottom 9, 8, 7, 6. So, remaining 5 will be there, that 5 is the median. That is what it is said, the median is the middle term if the number is odd and is the mean of the two middle items if the number is even. For a grouped data, how to calculate the median? In the basic definition of median, you learned that it is nothing but a middle term. If you are given a grouped data, the median can be calculated by this formula, that is L plus 1 by 2 into n minus c over f into h, where L is the lower limit of the median class and n is the total frequency, then this f is the frequency of the median class, then this h is the width of the median class and this c is the cumulative frequency up to the class preceding the median class. So, if you know all these data from a grouped data, you can calculate the median of the grouped data. Then quartiles. So far you learned mean, arithmetic mean, then median. The next fundamental concept in statistics is quartiles. These quartiles are the values which divide the given frequency into 4 equal parts. So, median divides the given data into 2 equal parts, quartiles divide the given frequency into 4 equal parts when the values are arranged in ascending order of the magnitude. This quartile are of two types, one is upper quartile and lower quartile. The lower quartile is the midway between the lower extreme and the median. You know, you've learnt median is the middle value when the given number of data is odd. If the given number of data is even, we need to take the average of the two central values. Here lower quartile is a midway between the lower value and the median. Upper quartile is the midway between the median and the upper extreme. For a grouped data, how these quartiles can be calculated? Q1 is the lower quartile, Q3 is the upper quartile. So, lower quartile Q1 is equal to L plus 3 by 4 n minus c by f into h, and the Q3 upper quartile is equal to L plus 1 by 4 n minus c by f into h. You can relate this formula with the median for the grouped data. Median for grouped data is L plus 1 by 2 n minus c by f into h. The quartile for group data is L plus 3 by 4 n minus c by f into h. So, the only included thing here is change here is instead of this 1 by 2 here 3 by 4 exists, then here also h exists, then in quartile formula also h exists. So, for the lower quartile this 3 by 4 exists and for the upper quartile this 1 by 4 exists. So, in median formula half exists, that is replaced by 3 by 4 and 1 by 4 in lower quartile and upper quartile. In this case also L is the lower limit of the class in which Q1 and Q2 lies. Then f is the frequency of this class and h is the width of the class. Class in the sense a group of frequency. Then the c is the cumulative frequency up to the class preceding the class in which this q1 or q3 lies. This is how the upper quartile and lower quartile for grouped data can be calculated. Next fundamental thing in statistics is mode. So far you learnt arithmetic mean, median, quartile. The next thing is the mode. The mode is defined as the value of the variable which occurs most frequently. That is, the value of the maximum frequency is called mode. In the case of simple data, for a grouped distribution of data, this mode can be calculated by the formula L plus del 1 by del 1 plus del 2 into H. Here the L exists, H exists as it is in the median formula and quartile formula. In median and quartile formula, that L is the lower limit of the class. Here also that L is the lower limit of the class containing the median. Then H is the width of the class in mode formula. In quartile also this H is the width of the class. Then del 1 is the excess of modal frequency over frequency of preceding class. Then del 2 is the excess of modal frequency over following class. Then H is the size of the modal class. If you know all these values, we can calculate the mode for a grouped distribution of data. For a frequency curve, next let us go to the mode in a frequency curve. Let us imagine a frequency curve. In that frequency curve, the abscissa of the highest ordinate determine the values of the mode. Here you learnt the general formula to calculate the mode in a grouped data. If the data is given as a curve, frequency curve, then mode can be obtained from that curve by knowing the abscissa of the highest ordinate. This abscissa of the highest ordinate determine the values of the mode. There may be one or more mode in a frequency curve, but in the case of grouped data using formula, only one mode will be there that can be calculated using this. But in the case of a frequency curve, there may be one or more mode in a frequency curve. Those modes are named as single mode, dimodal and multimodal, where single mode means curves having a single mode are termed as unimodal, and those having two modes as dimodal, and those having more than two modes are multimodal. This is how mode in a frequency curve can be classified. Then in the mode explanation, following observation is obtained. If the data is a symmetrical distribution in the sense equally distributed. So in a symmetrical distribution, the mean, median and mode coincide. That means all the three are considered here: arithmetic mean, then median and mode. Quartile is not taken into account here. So in a symmetrical distribution, the mean, median and mode coincide. For other distribution or non-symmetrical distribution, they are different and are known to be connected by the empirical relationship mean minus mode is equal to 3 into mean minus median. Mean minus mode is equal to 3 into mean minus median is the empirical relationship connecting the mean, median and mode for non-symmetrical distribution. For symmetrical distribution, all the three will coincide. You can apply all the three concepts in this example. So far you learnt arithmetic mean, then median, quartile and mode. In this example, you are asked to calculate the median and the lower and upper quartiles from the following distribution of number of marks obtained by 49 students in a class. Find also the semi-interquartile range and the mode. You know the formula to calculate mode. The formula to calculate mode is equal to L plus del 1 by del 1 plus del 2 into H. Like that formula to calculate lower quartile and upper quartile. You can apply that formula and you can calculate. The number of marks obtained by 45 students are given as a frequency class in this table. So, frequency class 5 to 10 marks, number of students is 5, then less than is 5 and more than is 49. Out of 49 students, these number of students are 5 to 10. Then 10 to 15, number of students 6. So, 5 plus 6, 11 students are there. So, 11 students, then 44. Like that the class of data is given. For this data, you are asked to calculate the median and the lower and upper quartiles and the mode and the mode. Solution to the above problem can be obtained by considering the formula for the median. Median is equal to L plus 1 by 2 into n minus C over F into H. This is the formula. Now substitute the values here. L is 15 in the problem plus this n is 49. So 49 into 1 by 2 will give 49 by 2 minus 11 over 15 is a frequency and the width of the class is 5. If you simplify this, you will get 15 plus 13.5 over 3. Simplifying this, you will get 19.5 marks is the median for this sample. Then lower quartile. This lower quartile is denoted as Q1, which is equal to L plus 1 by 4 into n minus C over F into H. This is the formula to calculate lower quartile. Now substitute the values. So Q1 is equal to L is nothing but 15 plus 1 by 4 into n is 49. So you get 49 by 4 minus C is 11 over 15 into 5. So simplifying this, you will get 15 plus 12.5 over 3 is equal to 15.4 marks is the lower quartile. Like that the upper quartile will be Q3 is equal to 25.75 marks. This is the upper quartile. Then semi-interquartile range will be equal to 5.175. This semi-interquartile range is obtained by taking the average of lower quartile and upper quartile. Then mode of the data is obtained from obtained as 18.2 marks. So this is these are all the values for the data given here. In this lecture, we learnt about statistics, arithmetic mean, median, quartile and mode are the concepts we learnt in this lecture. Arithmetic mean of the class gives the average value of the group. This arithmetic mean is calculated by shortcut method and step deviation method. Then median is the middle term of array of numbers. then mode is the value of the variable which occurs most frequently. These are all the concepts we learnt in this lecture. After listening to this lecture, you can answer the following questions. Define arithmetic mean of a group. What is known as median? Define mode of the group of sample. Thank you.